Okay everyone, welcome to video 2 for section 9.3, independent samples for two means. This time we're going to look at confidence intervals. And what I want to call out is that the first two steps in your panic method are going to be the exact same steps that you will encounter in your hypothesis testing. So P still represents parameters, where you're going to define both your parameters and your random variables. A is also going to stand for assumptions, where we are going to go through our checklist of those 4 items. So I'm not going to spend too much time here, but just remember and just note that the definitions that we have for x bar 1, x bar 2, mu1, and mu2 are the exact same definitions that we came up with when we were looking at the hypothesis testing section. So we're going to jump ahead to assumptions. And our assumptions are going to be the same. Am I working with simple random samples? Are my samples independent of one another? Do I know if each of the populations are normally distributed? Or do I have a sample size of 30 or more without outliers? And remember, if we are given the data, we're probably going to have to go through our checks from section 6.4. Finally, do we know the population standard deviation, or do we know sigma? Now we're going to move into the name of our procedure that we're going to use. Since we're working with a confidence interval, it should not be a shock that we're going to be working with something with the word interval in it. In this case, we're working with 2 samples, so we are going to work with a 2-sample t interval. Most likely it's going to be a 2-sample t interval because you probably are not going to know the population standard deviation. I didn't mention this in the last video, I'm sorry. But what I will say here is, if for some reason you know the population standard deviation of both of your groups, then you would use a 2-sample z interval. But again, I am going to really stress it here, you are most likely not going to know sigma at all. So the next best thing that you're going to have to do is work with the sample standard deviation, which you're going to be able to calculate from each of the 2 samples that you've been given. We're going to move on to our background information before we actually jump into our calculator work. But again, our point estimate, which we did talk about as our sample statistic in our hypothesis test, is going to be x bar 1 minus x bar 2. Remember, this is just you taking a subtraction of the 2 sample means. From here, we're going to construct our confidence interval. Remember, your confidence interval is where you're going to take your point estimate, or in other words, your sample statistic, and we are going to subtract the margin of error to get the lower bound, or add the margin of error to get the upper bound. But what I want you to note here is that notice that x bar 1 and x bar 2 are in brackets. So this is really just meant to be a grouping symbol. Basically what I'm trying to tell you is that this represents one value. Or one number. I'll actually do this in purple because that red did not work out too well. So again, if we kind of go down the rabbit hole and you're like, okay, great, I know how to get my point estimate, or in other words, my sample statistic. How do I get my margin of error? Your margin of error is where you're going to use your t critical value and you're going to multiply it by that standard error. So remember that this representation here is your standard error. And again, that's going to come from, that also came from your hypothesis testing notes. How do you find your critical t-value? This is going to be dependent on what confidence level we are deciding to work with, as well as the degrees of freedom. And remember, if you don't know how to calculate those degrees of freedom, or you're really itching to calculate them on your own, please go back to the hypothesis testing video. Now we are ready to jump to our calculator. So within our calculator, we're going to go to Stat, arrow over to Tests, and this time we're going to select option 0. And this is going to be a, maybe this is a shocker, maybe this is not, this is a 2-sample t interval. So I've said this in class before, but I will say it again. Remember that when you are working on these types of questions, if you are asked to do a hypothesis test, usually a good indication of that is you're going to be given a significance level, or they're really going to say, run a hypothesis test. Make sure that when you are going through your list of options after you've gone into stat and then over to tests, is that you are selecting something that has test in it. Likewise, if you are asked to do a confidence interval, you're most likely going to see the word confidence in there, or you're going to see a larger percentage, or you're going to see the word interval in there. So in that situation, once you go into the test option, you are going to want to select an option that has the word interval in it. Once you've created your t-interval, if you are working with data as opposed to stats, which we had addressed in the previous video, you're going to make sure that you have your data in lists. So list 1 for group 1, list 2 for group 2. Why make it more confusing? Once you go in and you select data, it's really just going to ask you, okay, if you want me to work with data, just tell me which lists you want me to pull from. The default is probably going to be list 1 and list 2. And I would definitely say work with those. Unless you accidentally deleted list 1 and list 2, then you would want to make sure that you are putting the appropriate lists in there. Your frequency 1 and frequency 2, you should probably just leave these as 1 unless you created frequency tables, which we have not done in class using our calculator. Then you're going to indicate your confidence level in its decimal form. And then our new option again, is it pooled or is the data pooled? We're going to say no, most likely, because we do not know if the population variances are equal to one another. And again, that probably should be stated clearly for you in the question that you're working with. Finally, we come to our conclusion. So as before, we're going to state our confidence level. We're going to note we are looking at the mean difference. In some way, shape, or form, we want to talk about that mean difference, or maybe if you feel more comfortable or it seems more logical in certain situations, you can say average difference. Then we're going to use the lower and upper bounds to cite the relationship between our population mean from group 1 and our population mean from group 2. So if the two bounds are both positive, so in other words, if you are looking at your confidence interval and your lower bound is positive and your upper bound is positive, we need to establish what that means about the relationship between mu1 and mu2 from the lens of a subtraction that's happening. So if we are looking at mu sub 1 minus mu sub 2 and they're giving me a positive number from doing a subtraction, that must mean that mu1 is bigger than mu2. That's the only way that when we are subtracting with numbers that we would get a positive number as a result. So here we would say mu1 is greater than mu2. Now, if we flip this around and we say that both of the bounds are negative, what does this mean? Well, I'm going to come up here and I'm going to kind of try to adjust this a little bit. There we go. So what this means is if we do mu1 minus mu2 and we get a negative number, well, the only way that that can happen is if mu1 is small and mu2 is big by comparison. Because again, that's the only way that when we're doing a subtraction problem that we're going to get a negative result. So in this case, we would say mu1 is less than mu2. And finally, if we are working with a situation where the bounds contain 0, and the only way that that's going to happen is if the lower bound is negative and the upper bound is positive. Because again, 0 has to kind of appear there. If you look at a number line, as you're going through the negative numbers, you have to pass through 0 or hit 0 before you can get into the positive numbers. Also, as a side note, if you are wondering, well, like, what if the lower bound is positive and the upper bound is negative? That can't happen. Our confidence intervals go in order, in numerical order. So there's no way that we would ever have a positive number be smaller than a negative number. Hopefully that is clear, despite the audio, just having the audio. So if the bounds contain 0, we cannot conclude the relationship between mu1 and mu2 because Essentially, you're giving your audience all three options in that interval. You're saying, because you have negative numbers in there, because you don't really know where the true average difference or mean difference is, if it's negative, that means mu1 is less than mu2. If it's 0, then that means mu1 is equal to mu2. And if it's positive, that means mu1 is greater than mu2. So you've given every single option that could happen between the two means when you are subtracting them. So this is why we say we can't conclude anything, because if you give me everything, I don't have any direction to go off of. All right, so now we're going to move to an example. So hop over to video 3.